Thank you so much, Bob. And now we're going to bring Jay into our mix to give his perspective, especially from CAMP, and how the verification for SPaT and MAP messages have been going. So, Jay?
Thank you, Patrick. Good afternoon, everyone. What I would focus primarily on the vehicle-centric application called red light violation warning. We've been developing these applications and test vehicles for a number of years now, and have had a chance to test many of the deployment or intersections around southeastern Michigan. And I'll talk about what are our findings and what are the tools that we have to develop to make sure that the SPaT and MAP transmitted at those intersections confine and conformance to the standard, as well as the needs for the application, which is red light violation warning. So with that, what I'll talk about is why do we need a SPaT and MAP verification? What are our preliminary findings when we started testing our test vehicles along the intersections in southeastern Michigan where deployed SPaT and MAP? That led us into development of a verification tool and further testing that we conducted using the tool, and what our findings are and the recommendation for and particularly actuated intersections. So in order for the reason why we need to have a SPaT and MAP so that vehicle manufacturers, as you know, are embarking on productionizing the connected vehicle technologies, and one of the applications is called red light violation warning. So we would like to have the intersections communicate properly and interoperably, basically, with the vehicles. This will also help deployment of SPaT challenge initiatives in terms of if we have the verified intersections, and we've been talked about a number of times, that how do you know that all these intersections that's been deployed under SPaT challenge, how do you know they're all verified, and what is the process of verification, and what is the minimum requirement for verifications. We also would like to make sure that all the information transmitted within SPaT and MAP meets the SAE J2735 specifications, and the data and the valid required data elements are properly filled in those message transmission. So with that, what we started doing out is using a test vehicle to drive around at deployed intersections and collect data and observe what's going on. That was a kind of a burdensome and unsafe practice, primarily because you have to drive through each and every lane to see if I'm getting the map correctly, SPaT information correctly, which matches with what I receive and what's being transmitted. And many times we have to stop and observe if the signal head is actually changing the phase information, which matches with what's received in the vehicle as a SPaT information and so forth. It's a time-consuming and error-prone process. We also, during those process, we figured we ran into several situations in which we found that when SPaT and MAP is transmitted, application didn't do any good and did not work. And it found out that when those two messages are transmitted, the intersection IDs are not correlated, meaning they're different in the same for a same intersection. So application did not know what to do with it. Similarly, in cases we also had experience that an intersection was partially mapped, meaning out of 4 lanes, only right 2 lanes were mapped. And if you were to drive your vehicle on the left 2 lanes, we don't see any information coming out, and it looks like the intersection is not working. And it turned out that, yeah, the maps were missing. In some cases, we also learned that an RSU was using pedestrian crossing phase and time information and sending it as actual phase and time information for the intersection, which caused different problems, and we started getting flashing red ball instead of actual phase information. So there were a lot of things that were not properly transmitting the information, and the conversion from a controller to the SPaT message and received SPaT message, they were inconsistent and incorrect. So all these things brought us into development of a tool, so we don't have to spend an awful lot of time figuring it out what actually intersection is doing. So what we did is develop a handheld portable tool which consisting of an OBU and a tablet which actually becomes which is actually a device on which a visualization is shown about the received SPaT and maps. So OBU receives the information, it converts that packet data to and serializes its information as per the J2735 to a proper values, and that value is transmitted over Bluetooth to a tablet, and tablet overlays that information using Google Map and shows you what's the current value of the SPaT information, including an icon that shows what the current phase information of that intersection is, or that particular signal head, and you can literally watch that it turn its phase when the time runs out, and that you can watch it against its visually watch against what's transmitted as a phase information and time information, and it also shows the map of an intersection is overlaid on top of a visualized satellite view of Google Map. So this helped us evaluate intersections, performance, and verification much quicker and much better, and it also allowed us to both visually see the information as well as collect the data for post-processing. So this particular is a very handy portable device with a mag mount antenna, DSRC. We put it on the top of a vehicle with the OBU turn on and activate the application on the tablet. You don't have to drive through intersection. You stop at an intersection nearby where you have a DSRC range, so you can receive all the messages from all the directions from that intersection, and it shows you all the information simultaneously. So now let me move on to using this tool, what we have discovered as we did some testing. So in this particular case, this shows you what are the things that you can test using the SPaT and map for SPaT and map conformance using this tool. As I mentioned, you can visually verify certain elements, and also you can generate a report as a post-processing to see exactly what's going on. One thing is not capability of this device is that we cannot actually verify that what is actually produced by the signal controller is the same information is translated by for the SPaT and the same information is received by the vehicle. That piece is still missing and is not doable through using this test tool. That requires additional information coming out directly from a controller. Moving forward, let me just touch upon a couple of scenarios that we experienced using this tool and data that we collected and post-process. Again, our application and verification and testing for this using this tool was focused around a red light violation warning. What is required for an application to perform as intended? As far as we see that, yeah, it is conforming to the intersections that we tested, conforms to the J2735. The data elements are populated as required by the standards, and all this information is right. However, the behavior of some of those actuated signalized intersection were kind of conflicting in the sense that the piece of information that's coming out from SPaT, which provides two pieces of information. One is the phase information and the time information, and there are instances under which those two are not correlated, which makes it difficult for the onboard application to how to interpret that information and what action to be taken as a part of the algorithm. So this is what I'm going to focus on it in next couple of 3 slides. So in this particular case, what we have observed is that when a the mean end time, and which is a part of the specification, provides the information about the current time and how long will it take before the current phase will change on a particular the main artery. It's a very large number, around 3,000 seconds. However, when a pedestrian crosswalk button is pressed and or the pedestrian crosswalk goes into don't walk flashing light, that number dramatically drops from some large value to 10 seconds, which has been programmed by the controller. And at that point, it starts counting down to the point and the phase changes. So the sudden drop in a number from a large value to a small value may confuse the application, and also sometimes, depending upon where the vehicle is along the lane and near the intersection, certain pieces of information may provide incorrect behavior to the application. Similarly, what we have observed in a scenario, so this is what's happening. So as I mentioned, it starts off with a large value, it drops slowly counting down, and as it reaches a certain point when this actuation takes place, then it drops to suddenly a 10-second value, and then it changes, the phase change takes place. In this particular case, what is happening is that actuation can take place at two different levels. In one case, if it is on a main artery, the vehicle detection, which increases the passage time. But during that time frame, as you can see here, is the time starts at the mean end time set to like 20 seconds, then it goes down to 0, and it goes into green rest mode. Phase does not change, it remains green. When there is a passage time is actuated by the vehicle on the main line, it goes back up to 2.8 seconds and goes back to 0 again. So at this situation, the mean end time value keeps on changing 0 and some defined value, and it fluctuates between those two values. However, the phase does not change. On the second level of actuation, if there is a crosswalk button is pressed along the minor street or the cross street, or the vehicle is waiting to change or gain an access to the green signal, then again the mean end time value goes up to 12 seconds, and then it counts down. At that point, the actuation takes place. So you can see at two different locations, the value of mean end time can keep on fluctuating, and that is information that we receive as a part of the applications on the onboard. Application may get confused about it because the time has expired, however the phase does not change, and time goes back up again to some value, comes down again, and such forth. This phenomena, we have seen it here in Michigan, as well as talking to other colleagues in California. They have seen the similar kind of behavior at an actuated signals. So these two things I wanted to point it out, that this is where we see that the behavior of an application could be very erratic, in the sense that the application does not know what to do under those conditions. So what we have been proposing, and this is just one of the proposals from our point, is that instead of this value that keeps on going up and down, why don't we have a mechanism through which the values can be held, because controller does not know when the phase is going to change, depending upon, because it's receiving an asynchronous input from either the cross street or from the main street. And under those conditions, until it is ready to actually change, the timer is ready to count down and change the phase, hold that value to some specified value of end time, so that the timer does not go to 0 and the phase change occurs when that hits the 0 value. So this is the proposal that we've been talking about, and would like to get the feedbacks from the IOs and implementers. So this captures our end of what we have been doing in terms of verifying and testing intersections along in the southeastern Michigan areas, and also using the test tool, and also what we are observing, that is how we can get this to the point where the application does not get confused about it due to the information that's coming out as a SPaT and map. They cannot be correlated easily. So with that, that's my presentation here. I'd like to introduce